I'm going to do some demos and stuff, so holding a mic doesn't really work for me, but I've been told I'm not the quietest of persons, so hopefully I can just project loud enough. I missed the show of hands. How many people actually do real NLP in production as their day job? And how many people here are just learning this stuff? Hey, text, it's all the rage. We speak it. Language, that's all good stuff. So. Okay, so when people were saying things like stemming and morphology and all that kind of stuff, we glazed over, right? Some of you did, some of you didn't. Okay, so my name is Grant Ingersoll. I'm the CTO and co-founder of Lucidworks. As Alexi said, my day job, my day hat is go build out business around Lucene and Solr and we invest a lot in the open source and then we build products on top of that. I'm also the co-author, actually with one of Alexi's colleagues at Penn when he was doing his PhD there, of a book called Taming Text. So all of those people who raised their hands of, hey, this tech stuff sounds interesting, but I don't know what the heck it is, that book is for you. It's an engineer's guide to NLP and search. It doesn't get into all the math. It just gets into, hey, what are the concepts behind this? And then here's some code examples that show how to do this. It's primarily driven off of open source examples, so you may or may not find it useful in your journey with this stuff. A little bit of an ad for our company, real quick. We put on the largest Lucene and Solr conference in the world. I think last year we had over 600 people at it, companies from small mom and pop startups all the way up to Apple and Salesforce and Target and big name companies there. So this year it's in October in Austin, Texas. So if you fancy learning more about Lucene and Solr, you can definitely come to it. It's a very technical conference. There's not a lot of commercials going on there. We very much drive it towards helping the community understand Lucene and Solr. So with that, I'm going to actually, as I was talking with Alexi, there's a couple of different ways I could have gone. I could do a Solr talk of, hey, here's what's going on in Solr. Actually, if you go to our website, I just did a webinar on what's the latest in Solr. So if you're interested in that, just go download the webinar. Instead, what I'm going to do is actually talk a bit more about my book and talk about text and some ideas around how you can process this, and in fact, how you can build out, with a lot of great open source capabilities, a pretty decent question answering system. So in the book, I kind of walk through all of these different parts of text processing, ultimately leading up to building a very simple question answering system. So that's kind of the premise of this talk, and I'll talk about some of the things along the way. I'm going to kind of wear two hats. I'm going to talk a little bit about Lucidworks and some of the things we're doing with question answering and NLP and stuff like that, but then also put on the let's go sell a book hat and talk some about that. So before we get started, I always like to put out a big caveat, right? The text world, Alexi said, it's often called unstructured data. I think that's kind of it's one of my pet peeves of mine, is that text is actually very highly structured, right? We're just not very good yet. We're getting better at helping computers understand how to treat text. And in fact, I often think the reason why text is called unstructured is because all the database salesmen back in the 80s knew that they couldn't handle text, and so they said, oh, well, it's this unstructured thing, because it's almost like a derogatory thing, where structured, well, that sounds great, so we can sell structured, we can't sell unstructured. Whereas nowadays, I think we all know that and recognize that we live in this fuzzy world, right, where there's a lot of ambiguity and stuff like that. And in fact, I think, one of my favorite movies and book series is Lord of the Rings, so thinking about how does text relate to that, I think you often, when you're coming across text, and the VigLink guys did a great setup for this, you often run into all different kinds of characters when it comes to text. There's a whole lot of text out there that's just, evil. There's people who write bad things. There's things like sarcasm. There's people who are mad, etc., right? And so they take all this stuff and they're working against you. There's actually whole tracks in academia around how to deal with adversarial situations, right? Where, people are actually being bad actors. And of course, there's all kinds of things like jokers, right? You've got people who are sarcastic, people who are telling jokes, all of those kinds of things. How do you deal with that kind of stuff in text, text, right? Again, you know, one of my favorite sayings is there's a reason why the saying is the numbers don't lie, right? Nobody ever says the text doesn't lie. Text lies all the time. People lie all of the time, right? So you've got all of these different characters coming in, and hopefully at the end of the day, what you come out of this is you get to be the hero, right? One other one that's pretty interesting, and I think the VigLink people got at this too, is there's a whole lot of unicorns in text. Just think about the fact that there are new products that come out every single day. You've never seen this thing before. What are you going to do about it? I don't know what that iPod thing is, or iPhone, or whatever it was, until that actually was announced and came out, and you had to deal with all the different spelling variations and all of that. So there's all this really unique stuff that's happening in text that you have to be ready to deal with. And you know what? It's really hard. And so at the end of the day, you kind of got to keep in mind that you often are just striving for good enough here, or better than what an individual person could do, or better than what, you know, the previous state of the art was there. The other thing I like to kind of seed you with, especially as you're on this journey of getting into text, is that take it all with a grain of salt, all right? You're going, you know, a lot of this NLP stuff and doing all of these kinds of things that they talked about, all the fancy algorithms, those are really great. Your day-to-day isn't going to look like that. You're going to spend a lot of time on pre-processing. They talked about what you had 20 different data sources, right? Let me guess, they're all in the exact same format with all the right tags and all of those kinds of things, right? Yep. Okay, so you know what this is about, right? Content comes in, right? If you don't believe me, just go try writing a web crawler, okay? This big internet the whole entire world is on. You think we would all have a standard way of dealing with all this kind of stuff? Guess what? We don't. And so you have to deal with all this crap up front. And then you're going to spend a lot of time on feature selection, right? It's often the case that these fancy algorithms, they may or may not work simply by the fact that you didn't do good feature selection. What do I mean by that? That might be something like choosing which words in a sentence you want to keep as part of your machine learning algorithm. So when he was showing you that big table, Gabor I think it was, that big table that had, you know, first character and he had the, you know, all the matrices and what they're contributing, that's your feature selection process. There's a lot of good tools out there that help you with this. Other things is you're going to do a whole lot of staring at text yourself, and one of these days this light bulb's going to go off and you're going to be like, oh, I get it now. And so you're going to dig in, and then things like validation, content extraction, et cetera, et cetera. Long story short, start simple, try out the tried and true approaches. Chances of you actually innovating on something really new and unique in this, maybe not so good right off the bat, so start with what's easy and get going from there. You'd be surprised how far you can get off of just kind of common sense and open source, and then iterate from there as you learn your domain more, as you invest more resources, all of those kinds of things. So that's kind of my caveat. It's a lot of fun. It's a great field to be in. It's also really hard, and I firmly believe that as an engineer, you want to work on hard problems, so it's a great space to be in, and I think speaks to a lot to the popularity of this group and something that you can grow on here. Okay, so with the little warning up front, one of the things I kind of wanted to dig into is, how many people watched Watson beat, Ken Jennings, and does anybody remember the other guy's name? No, that's a good question to ask of a system, right? So question answering is essentially, I think, what many of us in the search field think of as the future of search. It's great to get 10 blue links, and you have to go click on them and then go read through some article and try to figure out whether it answers your information need or not. I think we all dream of the day when you can just simply ask, or you can type in your question, and it comes back with just the right amount of information, right? And so if you ask the question, who is the president of the United States right now, you should get, Barack Obama. And ideally, you could also ask the kinds of questions of like, what were the causes of the United States Civil War? And you would get back the right amount of information, right? That's what, kind of the ultimate dream is of question answering, I think. The really cool thing is we are finally living in an age where this stuff is becoming more and more practical. I built my first question answering system in when was that? 2004. People have been working on it for years before that. You're finally starting to see with a lot of these big data techniques and much more capable open source projects, as well as, you know, kind of standing on the shoulders of giants, that we can do a lot more than we ever have. The fact that you can pick up your phone and say, hey, you know, what's the stock price for whatever company you're interested in, is a really cool thing, and there's a lot of interesting processing that goes into that. I'm going to show you a little demo of what it looks like in the book context, and then I'll talk through kind of what are some of the steps behind that. Just to set the stage a little bit, the book one is very toy in the sense that it is a fact-based question answering system. It's not doing a lot of reasoning. The way that works is you take a version of truth, a data source, if you will, and that acts as kind of the baseline which you're going to go and try to determine what an answer is from. And then we're going to do a bunch of processing on that to hopefully come up with the answer to a particular question. So the causes of the Civil War stuff, I'm not going to do that here, but hopefully we can answer some interesting questions about facts that are assumed to be true in the index or in the database, excuse me, the database that we have here. So good Lord willing, live demos are always a fun thing. One of the things I just do is, in the book, is I walk you through kind of starting with search, how to build up more interesting things like clustering and classification and tagging and all of these concepts. And then finally, towards the end of the book, we end with, all right, let's tie all of these things into a question answering system. So what we do there is we take Solr, we index Wikipedia into it, okay? And then we've added in some plugins into Solr that do things like question parsing and all of this kind of stuff. And at the end of the day, then, what I've got is a very simple interface built on Solr that is doing a search when it doesn't know how to answer a question, but then when you give it a question, it will try and answer that. So that's what you're seeing here. I've only indexed, it looks like there's about 8,600 or so actual documents in this. And so the only things I can answer are those things that exist in that index. I'm not bringing any other outside resources in, et cetera, which of course in a real system you would do. So I can come in here and I happen to know a few things like here. Say I'm a chemist, I might ask the question, what is trimethylbenzene? And you know, obviously that's a somewhat canned question. And I can do the search. Behind the scenes, I've gone to Solr and I said, give me some candidate passages that mention trimethylbenzene, and then do some scoring things around that, right? Just like they were talking about, they go to Elastic to get their candidate offers, right? Then they funnel those down. Same kind of process that you're going to do here in a search system or in a question answering system. And so if I scroll in here, you can see, for instance, what we then do is extract out of this much larger document this passage that says 1,2,4-trimethylbenzene is a colorless liquid with chemical formula CH, and then there's some other text in there, and I'll talk about some of that later. But you can see I've also actually get a few other candidate things. These are the ones that actually came out of the scoring process. The interesting thing here is I also show you the underlying document that provided these answers. And you know, it can go and ask other questions of this, like who is 10-minute warning? And here it does, 10-minute warning is a hardcore punk band from Seattle, Washington. You can see again, I've got some extra stuff here. This kind of starts to speak to some of the problems that come in around asking these questions. If I asked, you know, something like, you know, who is Big Link, you know, it's going to come back with nothing because that's not in my index, right? So just to kind of set the stage there and set expectations, right? But so you can see that we're extracting content out of it. It's actually using this, in this particular case, it's using that full document to get those particular answers. So far, so good? Makes sense? Yep.
So the power set that was bought by Microsoft was attempting somewhat harder problems like asking questions, who did the 49ers play in 1994? They're looking for semantic relations, where this is largely lookup by name or proper name, right? Which is fairly straightforward. So can you do anything in semantic relations?
Yeah, of course, and you know, I don't get into, we cover some of that in the book, and I'll talk about some of the things that we do in the book context, but of course in a real world system, yes, you're going to bring in lots of other things beyond just the basic passage retrieval.
The power set folks have a lot of problems doing semantic relations. They never got it to scale.
Yeah, well, scaling this stuff is always one of the hard parts.
They never got it to scale.
Right.
So if you're talking about things which are essentially name lookups, which are fairly straightforward, can you go beyond that and answer more deep questions?
Yeah, I mean, I think you're starting to see more and more people be capable of that. I've worked on systems just in, I won't say it's solved by any means. I know I'm not saying that, right? So I think you're starting to see more and more people look at relationships between entities in the text and try to do reasoning on those kinds of things. I don't think it's a solved problem by any stretch, right? So, you know, and it's certainly one of those things that's really hard to scale, right? I'm not aware of anybody offhand that I know who's doing it, you know, who's doing it really well, but, you know, they may be out there, I just may not be aware of them. So, so that's kind of the basis here of this, of what we're getting at. So let's dig in a little bit, you know, to the gentleman's point here. This is obviously a very simple query workflow based off of looking at facts like around named entities or other kinds of things. Everybody familiar with named entities? People, places, locations, all of that kind of stuff. So if you think about, like, so what we do in the book, one of the things we do is very simple QA workflow. One, we've got content coming in. So we've got essentially, you remember all that pre-processing stuff that we talked about, right? So some of the typical things that you do is first, you know, you've got to recognize a sentence, right? You think, oh, well, what's so hard about that? You know, a 5-year-old can do it. You know, computers these days are actually quite good at it, but you'd be surprised how often they still are wrong. You know, that's usually typically pretty high capabilities there. And from there, kind of, that kind of degrades down. The next step we do is, as we're indexing, we just take and we're using an open source project called OpenNLP, which is, this is a decent library. It's not the best library out there, but it kind of can get you going pretty quickly on this kind of stuff. And they've got general models for doing things like named entity recognition and sentence detection and all of that kind of stuff. So as we're indexing, as this content comes in, we break it up on sentences. We take each sentence, feed that to the named entity detection, and we mark up the content of this is a named entity, this isn't, et cetera. And then we take and we send that into your search engine, and then that makes it available for us to query. On the question side, this is really where I think you know, a lot of work is obviously can be done here in terms of enhancing that content as it's going in. Same thing on the question. The question comes in. The first thing we've got to do is parse that, you know, such that we tokenize it, we split it up into chunks, et cetera. And then we need to do this thing called determining the answer type. Right? And if you think about it, there's a lot of different kinds of answer types out there. This is essentially a classification problem. Is this person asking for or is this question about a person? Is it about a location? Is it about, you know, whatever category you want in terms of the data that you have? And then out of that, we need to then generate a query against our search system, right? And then from that, get the search. That gives us back kind of a candidate set of results. And then we've got to go and do ranking of those. If you go read, like, for instance, the IBM Watson paper and stuff like that, they'll tell you about, they spend a lot of time on answer types, and they talk about, you know, somewhat about their ranking problems, and they talk about how they bring in different authoritative data sources and all of this kind of stuff. It's a really nice read, but, you know, essentially you still can simplify it up to some of, you know, essentially something that looks like that. Obviously in the real world you would dig in a lot more, but for those people who are getting started, this is a good way of looking at it, et cetera. Digging in then, you kind of start to think about what are the building blocks for doing this text processing stuff. You know, a lot of great stuff from the VigLink people around all of the deep learning and all this, you know, very advanced stuff. There's a lot of just fundamental things as well that people have been doing for a lot of years around this. How many people, you know, remember their high school grammar class? How many people remember it fondly? Anybody? So all of that stuff gets to come back to you. So things like part-of-speech tagging, parsing, breaking down sentences into things like noun phrases, verb phrases, adverb phrases, part-of-speeches like adjectives and adverbs, and all that stuff that you probably wish you had forgotten, is going to come back into play here on this stuff. Although interesting enough, the deep learning stuff maybe doesn't need as much of this anymore. At the end of the day, these things are potential features for you. They often go into building NLP systems. I walk through a lot of this kind of just foundational stuff in the book, and so you may find that useful in your journey here. But essentially this is building out kind of some of these things around how do we parse and how do we detect sentences, how do we recognize when something's a named entity and all of that kind of stuff. Well, first, of course, it's got to be a noun and all of that kind of stuff, right? So those are kind of your building blocks. And again, I'm just kind of giving you a high-level view of this. Obviously, you could go spend your entire life just focused on one particular area of this. You could get a PhD, et cetera. I think we covered NER already, so I won't go into too much of that. But it often comes into these systems of, a lot of times these systems are really focused on how do I find the named entities or the interesting things in it, and then what's all of the surrounding stuff around those, such that I can start to make, I can start to reason about it and do other interesting things. From there, we take, what we do is take and build out a query parser. So that query parser needs to be able to take in a natural language query. So if, for instance, you've ever used Lucene or Solr or Elasticsearch or Indeka or Fast or whatever search engine, much like with a database, they usually give you a very structured query language where you're doing Boolean logic, you've got fielded searches and things like that. What your users want, however, of course, is just interact naturally with it using human languages, right? So what we do is build out a query parser that takes in the natural language query. We classify it into, I think in the book we use just 4 different answer types. They actually look like the training set that we use is a pretty simple one that looks kind of like this. I can scroll in on that a little bit. Where essentially I've got a category field. So essentially this is the label that I'm applying to this question, and then an example of a question. So I know you probably can't read that in the back, but for instance, this particular one is looking for a person, or it says this particular item is a person, and the question is which boxer representing Canada won the 1988 Olympic super heavyweight gold medal, defeating Riddick Bowe of the USA in the final, right? So that's an example of a question that is looking for a person, and there's a bunch of different ones in here. This is essentially that same annotation problem that they were talking about. You're going to spend a lot of time doing that kind of stuff. That's the fun stuff, or the not so fun stuff. But it's often necessary especially for getting started these days. So from that, we generate a Solr query underneath the hood. One of the things that's interesting, unlike keyword search, is you actually have to know where in the document this matched. If you're familiar with Lucene and Solr, at a very low level, this is called a span query or a positional query. So what we do is we take that answer type that we got, and we take the original text of the query, drop some words off of it and kind of massage it a little bit. We bring those together in a span query which says, I want to find these words with this answer type within a certain window, okay? And that now forms my candidate system, right? And from that candidate system, we can then go and look at how to score that, and I'll cover that in just a minute. Real quickly on the answer type classification, it's essentially, like I said, a classification problem. You can see there's a bunch of different examples of that. The most popular things that most people are looking for: person, location, organization, time, etc. So all of that's covered in there. We also show you how to do that. That problem then of scoring all of this stuff, obviously there's much more sophisticated approaches out there. This is a very simple approach. I think AT&T published on this back in the mid-90s. Works okay. You know, you can get kind of what you saw in the book. Obviously, you know, there's a lot more that we can do off of it. But essentially, we take and we find exactly where we match. And then, you know, what we're doing is looking at the context around that. We want to make sure that the answer type, because remember at indexing time, we indexed the kind of the tags that said this particular thing is a noun or this particular thing is a named entity, etc. So when we go to search, we want to make sure that that named entity is in the matching window first and foremost, right? And then we want to do some analysis to try to figure out what is the actual answer out of that system, right? So it's pretty simple and works okay. You know, you're not gonna blow anybody away with the quality of this system. But you know, for somebody who's getting started and trying to learn from all of this, you know, it's a good example of how to go about doing this kind of stuff. So with that then, I'm going to shift gears a little bit and talk about some of the things that we're doing around this, kind of building off of taking this classification stuff and all of that. Because I think when you think about search, again, if we go back to this assumption that people want to interact naturally with the computer system via natural language, you need to then be able to churn that stuff into, you know, queries to your system and then retrieve all of that stuff out of it. So at Lucidworks, we build a product called Fusion, which sits on top of Solr. Kind of three core foundations to it. One is, you know, this kind of notion of signals, which is, you know, kind of how can we gather information from the way users interact with content and then feed that back into the system such that we have more insightful access to the data. So they talked a lot about clickstream data, for instance. That's an example of a signal to us. We can take clickstream data and automatically churn that into more enhanced search results, as well as things like recommendation engines, etc. Other examples of a signal might be the fact that you and I emailed, or we're emailing all the time and we're talking about Solr together, or we're talking about sports together. Another example might be a Twitter feed where you're sitting there looking at hashtags that are mentioned and using that as counts on how interested people are. We take all of that data, shove it into another index in Solr, and then as we're interacting with the data, we can then leverage that for providing essentially popularity based enhancement of the original search results. So for instance, you can take your core e-commerce catalog, which is already running on Solr, you don't have to touch that, index all these signals right alongside of it, hit Fusion, it will go and get the weights for that particular query to figure out what people care about, and then search against your core catalog to get back the results that match on content as well as match on popularity or on the signals, for instance, as an example. So with that, then, one of the things that we often have people ask us for is, how do I get better insight into what a user's intent is, right? And that often comes down to, how do I classify the user's question into something more interesting. So I'm going to show you this is a little prototype I've been working on. It isn't in production yet, but you know, we're getting there with it. And so with that, I'll just shift over here and come into Fusion. So like I said, you know, one of the cornerstones was the signal stuff. The second part of it is go and deploy more Solr. Ask more interesting questions of Solr. You already have Solr deployed. Wouldn't it be great if your system was just simplified, you could just deploy more Solr and ask more interesting questions of it? You already know how to do that. The last part of it is we really just provide a lot of tools around it in terms of managing it, things like pipelines and relevancy tools and system dashboards and all of that kind of stuff. So I'm going to kind of walk you through a little bit of two things. One of the things that we have built in here is a search system or a search UI where you can come in and just have right off the bat, you know, enterprise search within your system. And what I've done is we've actually taken a bunch of tax questions. So this is like people asking, hey, how do I take a home office deduction as an employee? And we've actually indexed that, and we actually have some categorization on that data, right? And so you can see I can do some questions here and, you know, interact with this data, and I can say things like home office deduction, and do a search here and all of that stuff. And so that's all well and good, pretty straightforward vanilla search going on. I'm just going to open up another tab here, and now I'm going to go into the admin capabilities here. You can see, for instance, we give you things like managing your data collections. You can run all of this multi-tenanted. You get information about what's going on. So here's my questions index. Along that lines, we then have what are called pipelines. Pipelines are essentially a lightweight ETL tool that you can scale out to do kind of pre-processing. Remember all that pre-processing crap that I talked about earlier? That is where you're going to spend all your time. We try to make that easier here. We have both index and query side pipelines. So one of the things we do is we actually have some training and NLP capabilities in here. So you can come in here and, for instance, this is building out a model of taking in that question and categorization stuff and building out a model automatically for you off of that annotated data. Right? So that's an example of an index pipeline. I have a second one here that then can take data as it's coming in. So you remember that diagram I showed you around QA, where as the content comes in, we've got to do sentence detection and then add the named entities and all of that kind of stuff, and then ultimately index it. This is a lightweight version of that. I'm doing classification of that data as it's coming in, and then I'm indexing it to Solr. For instance, if I wanted to do named entity recognition, I could simply just add a new stage here and fill in my rules and my model for doing all of that kind of stuff, and voila, I've got named entity on my content going in there. And if you want to train your own models and all of that, you can do that, right? So that's on the indexing side. Where it gets more interesting is on the query side. I can now take, as requests are coming in, and modify them as they're going. And I can build up lots of these pipelines. I can do A/B testing and all of that kind of stuff with it. So out of the box, I've got a pipeline set up here for this questions collection. It's doing things like saying, hey, which search fields do you want to search on? It's doing things like, what search fields do you want to facet on? You can put in logging stages, and ultimately you can send queries to Solr. And so all of this is drag and drop live. You can arrange these as you see fit, such that if you don't like that particular order, you can change them around. And my demo's not happy with me right at this moment. And you can see it all automatically updates and all of that kind of stuff. Let me just make sure I've got my order here correct. So one of the things I wanted to do for this demo is say, okay, if a question comes in, I want to actually try to understand what this user's interested in. So we took this data set, we trained on the question and the category, and now I'm going to, at query time, leverage that to maybe direct the user when they ask specific kinds of questions to a landing page, where it's like, this page talks specifically about your question, as opposed to giving them back those 10 blue links, right? So the way I do this is, at the query time, I've got a stage that I'm going to pop in here called just the NLP classifier that takes that model that I trained at indexing time. And so when the query comes in, it's going to look at that query and say, oh, this query is about home office deductions. It's going to add that into the request. And then downstream from that, I've got a landing page set up that says, whenever you see a category of home office deductions here, let me just make that a little bit bigger. Whenever you see a query that matches on where the category is home office deductions, I want you to provide a redirect URL that takes me exactly to irs.gov, small business and self-employed home office deduction, right? And so you can kind of build out these rules if you want. That helps kind of guide users to specific places in your site. You see this all the time in e-commerce shops, for instance. If you go to Apple and you search for the iPhone, they don't give you 10 blue links about the iPhone. They take you to the iPhone landing page. This is just one example of leveraging that upfront classification stuff to then go deeper onto what's going on. So you're probably saying, well, why wasn't this running before? I actually had it, I'm going to make my screen a little bit smaller here so I can see what's going on. I actually have this turned off at this moment. Let me turn that back on. I'm going to hit save. We're going to come back here, and good Lord willing, live demos. Home office deduction, what we just do, this is obviously like our search result page. What I've done then is you can see now it matches on that thing. It says, oh, there was a home office deduction question. We could do a full natural language question if we wanted there. And now it's returning out that it recognized that there is a landing page to go here. If you were building out your real search UI, obviously you would see that the response says, hey, redirect to this page or show that page appropriately in your application. In our internal search, we don't need to do that because that's not, there's no benefit for us to take you directly to that page here in that system. So that's just kind of an example of what's going on. Underneath the hood, there's obviously some classification going on, training, et cetera, parsing of questions. Some of the, at a high level, similar techniques to what I talked about in the earlier part of the talk. Any questions on that? Yep.
So, Grant, you have this, you showed like one of the nameted recognition was OpenNLP. What if I want to swap in Stanford for NLP? And what if you don't have it in there? Like,
right.
Can I drop in something of my own?
Yep. So in fact, with these pipelines, we publish SDKs for them. You can actually even, if you come in here, so for instance, let me just find the default one. We ship with a bunch of them out of the box. So things like extracting content from Word, transforming different format types. You can do things like regex kind of stuff in here. There's even a JavaScript stage such that if you want to provide your own integration there just to try things out, you can write your own JavaScript in there. It'll get injected into that. If you wanted to bring in, so for instance, Stanford has not a very friendly open source license. So as a commercial vendor, you can't just ship it, right? So if you wanted to do Stanford yourself, you could drop that in using the SDK. And so in fact, we've got customers who write their own pipeline stages all the time, pop them in there, they automatically show up in this list. You can go and take advantage of all of that kind of stuff, right? So, any other questions? Awesome. In terms of next steps around the QA, I mean, I think, the sky's kind of the limit here. There's a lot of capabilities. This is by no means a solved problem. Some easier things to think about or try out, like if you wanted to take the code base that's up on GitHub around this and say, hey, I want to try some of these more advanced things. Things like, I just showed you the whole window around it. Well, it's not too much harder to actually get in and try to get at the exact answer in most cases there. A lot of systems, I think Katrina, you hinted at earlier, using an ensemble approach where you're actually taking answers from lots of different data sources and then trying to figure out which one is the actual authoritative one. That's a learning problem in itself as well and can provide a lot of benefits. Like that was one of the things with Watson, for instance. They had so many different data sources that they had to bring together to answer that question in milliseconds, right? So that's a pretty hard and challenging problem. Things like more answer types, richer NLP resources, a lot of things where you can just bring in other lexical resources, gazetteers, dictionaries, all of those kinds of things to kind of feed them back in. I've got a very basic passage retrieval approach here and a very basic scoring model. Doing things like actually seeing what people are clicking on and whether they're rewriting their queries and kind of taking all that signal information to try to learn over time how to better answer questions. A lot of people also take and approach question answering as kind of a human in the loop, semi-automated system where, they have real people answering the hard questions and then those automatically get fed back into the system such that the next time somebody answers those or asks those, they can go off and it can be automatically answered. We can learn from it, all of that kind of stuff. I mean, the sky's the limit. This is just, really brushing the surface here. So again, targeted more towards the people who are getting started on this, not the people who do it for a living and all of that good stuff. So. If you're interested, published with Manning, that's us on Lucidworks. You can get a hold of me. I've got a few other things. I'll post the slides to Alexi. It shows you some basics on getting started and doing that, running that demo and all that kind of stuff. So, any last questions? Yep. So some examples of that? Well, I think Watson is one of the first, one of them that obviously performs at a very high level. I mean, things like Siri and Google Now and all of those things are bringing in. What's the secret methodology that I like for those things? I mean, I can't say to how those guys have implemented. I haven't implemented. I don't work there, but. Yeah, I mean, that's been traditionally one of the big problems, right, is you often have, you either have a rule-based approach where you've got people writing rules all day, or you've got an annotation-based approach where you've got people just tagging things and then you're learning a classifier from that. To I think your point earlier, the deep learning stuff is interesting from the fact that maybe you can get rid of some of these annotators out there. Or not have to use them as heavily. Hopefully that's going to reduce the burden. The annotation approach typically is cheaper since you don't have to pay those annotators as much compared to somebody who's more of an expert in a rule-based system. But I think, like what you guys presented as a hybrid approach is definitely where most people are, and that's been all the systems that I've implemented as well. So, that's probably where we're at right now, because I think you always have these edge cases where you just need that blunt force that says, I don't care what the score from the classifier says, I'm overriding that because my business says I should override that. And so that kind of gets to the practical, pragmatic side of it. So, any other questions?
Just kind of a futuristic question, right? Humans and sound.
Oh, jeez. Didn't somebody actually win or pass it earlier, late last year with a system? I think somebody did actually, according to the competition, win it last year. I don't know, it still wasn't quite there in the general purpose way, I guess. How close are we? I'm not good at predicting the future of that. The fact that IBM got on there and won Jeopardy, well, it's, when you go look at what they were doing, there's still, a lot of tried and true things in there. 10 years, 15 years, 5 years, somewhere in there. I don't know.
Like among your customers doing text search.
Yeah.
How, like of the overall set of companies using text and Q&A, like how good are they? How far are they from kind of?
Oh, well, first off, most people aren't even doing question answering yet, right? There's starting to be, like in the e-commerce and mobile space, there's more and more interest in that, especially, like the mobile providers, et cetera. They want to be able to do more and more of that. But like, if, that's basically companies here, right? Like it's the leading cutting edge companies who are, breaking new ground. I think you presented one earlier. A lot of people, people are just doing baby steps of how do I deal with all the noisy data that I have and then just make that searchable to begin with, right? Like that's not, search itself is not even a solved problem yet. So to all of a sudden say I'm going to do this harder thing, question answering, is even more challenging. Obviously, like I think within some domains you can be more effective there. Especially if you can kind of narrow down the user that's in there, or if you can deal with more, certain types of users, you can be more effective there. But general purpose, I'm still happy I can ask my phone a question and get back an answer, right? And so that's a big leap forward, just right there. But yeah, I would say it's a very small percentage at this point. Any other questions? Awesome, thank you, and thanks to BigLink for hosting.